Alright, this is section 12.3, areas of composite figures. Now if I had to pick the hardest section for this chapter, I think it might be this one here. So I would love for you to make sure you have your calculator with you while we're going over this, and you can pause the video as you need to take notes or to try it again. Really try to follow along on this one. We'll go over any questions you have on this section and on 12.4 on Wednesday, but remember you can always email me and we can answer questions that way as well. A composite figure is made up of two or more shapes. If you think of the word composite or compose, it's two things put together, two or more things combined. So to find the area of a composite figure, you're going to do two things. One, cut it into figures that are smaller or things that you have equations for. So if you look here, I copied this directly from your book. We know how to find the area of a parallelogram. We know how to find one for a triangle, one for a trapezoid, one for a circle. So you're going to cut this figure into little shapes that you know how to find the area of. Once you've done that, you can add them all together. Okay, so we don't have an actual equation that says composite figure because these figures are going to be different shapes. So if I had something that looks like this. Now, that's not a parallelogram, it's not a triangle, it's not a trapezoid, it's not a circle. But if I look, I see this is a half circle, and I see this is a parallelogram. So I could take the area of the half circle and I could add it to my parallelogram. Then I would have the full shape. Maybe you have something that looks like, let's do another one here, this. Okay, a little bit harder to see maybe, but I see a triangle here and a trapezoid here. So again, I can cut it into the pieces that I'm familiar with or the pieces that I know. So area formula for a parallelogram. Let's go over each of these individually. The area of a parallelogram is the product, and you're going to be multiplying the base times the height. So if this is my parallelogram, my height and my base are going to make a 90-degree angle. I have a base and a height. The area of a triangle is 1/2 any base times the height. So if this is my triangle, and this is my height, and this is my base, I'm going to multiply the base and the height because I see product there, and then multiply it by 1/2. Remember, multiplying by 1/2 is the same as dividing by 2. A trapezoid looks like this. To find the area of a trapezoid, we're doing half the product. So again, we're multiplying the height times the sum of the bases. Well, there's two bases, one here and one here. And then lastly, the one we had in the section before, circle, we know is pi times the radius squared. So number 1, it says find the area of the composite figure. Round to the nearest tenth if necessary. So if you look at page 569, you're going to see this figure. Looks kind of like an ice cream cone. Okay, it says that this measure is 16 millimeters and this is 6 millimeters. Now I don't have a formula that specifically says ice cream cone. So I know that I'm going to have to put a couple things together. So I like to draw them out first. I see the ice cream portion, which is half of a circle, and I see a triangle. Now I can label what I have. It tells me that This length on the triangle is 16, and this length is 6. And on the circle, it shares a diameter of 6 there as well. Now, I can write out the formulas for each of these. For the circle, I only need half of it because it's a half circle. So I need 1/2 pi r squared. Okay, so thinking about the circle, I see the distance all the way across. Well, that is the diameter. So to find the radius, I have to divide it by 2. So I can plug in, I have 1/2, because it's a half circle, pi times the radius squared. Now let's look at our triangle. Our triangle formula is 1/2 the base of the triangle times the height. Now this looks a little funny because the triangle is kind of laying down, but I see my base is 6 and my height is 16. So at this point, I'm ready to go to my calculator. Make sure you're doing order of operations. So I have to do my exponents first. Also, as a reminder, please use the pi button on your calculator. Do not type in 3.14 because you will be rounding too soon. So 3 squared is 9. I'm going to do 9 times pi divided by 2, or you could say times 0.5, and I get 14.14. 6 times 16 divided by 2 gives me 48. And I'm going to add these two together. Wants me to round to the nearest tenth. So I get 62.1 millimeters squared. Remember, area always has our units squared. So if I had to break this down into steps, I would first draw out what you have. Break it up into pieces, just like I said up here. Cut the figure into smaller shapes. Number 2, write out your formulas, like we did. And number 3, use your calculator. Let's try another one. The L-shaped countertop shown is to be replaced with a new countertop that costs $52 per square foot. What will be the new cost of the countertop? So this is going to go one extra step because it doesn't just want to know the area, it wants to know the price. I see per square foot, feet squared. I need my area. On page 569 it shows you a picture of the countertop, but we'll draw it here too. So it's an L-shaped. Shows on here that all of the angles are 90 degrees, right angles. They all have that box on them. 3 feet, 2 feet, 3 feet, and 10 feet. Okay, so I do not have a formula that says area for L-shaped. So I'm going to need to break this figure up. You may see it a little bit differently than me. I see this rectangle here, and this one here. If you cut it a different way, that's okay. You should get the exact same answer I do. You may have seen it this way and this way, and that's okay. But let's try it my way. I'm going to label the pieces. Okay, well, I see this part is 3 feet. Well, I know this entire part is 10, but if I don't want to include this blue, I know this is 3. So this bottom portion has got to be 10 minus 3. Then to label the blue rectangle, he said this is 3, and I need this entire side. Well, that's 2, and this is 3, so the whole blue side is going to be 2 plus 3. both of these are parallelograms, so I need base times height here, where my base is 3 and my height is 2 plus 3, or 5. And I need the base times the height here, which the base would be 10 minus 3, or 7, times the height, which is 3. So again, we started with our picture, labeling the parts. Second, we used our formulas, and now you can go to your calculator and you can plug in. 3 times 5 gives me 15. 7 times 3 is 21, for an area of 36 feet squared. But again, it didn't ask me what the area was, it asked me what the cost was. Well, the cost is $52 per square foot. So I need to multiply $52 times 36. Per tells me that I need to multiply. So 52 times 36 gives me a total of $1,872. So when you go to homework, I want you to draw out your pictures first. So if I were to look at homework number 1, I see something that looks like this. Okay, I would see one parallelogram and another parallelogram. In the next one, like number 2, okay, picture looks like this. I would see a half circle and a triangle. So break each of them up, maybe draw them as a whole, and then draw their individual pieces, and then use this front page with all of your formulas on it. It's also in the book. I am not going to expect you to memorize any of these area formulas. Same going on from here. You won't have to memorize them. They will all be given to you. But you will need to know what each letter stands for. So in all of these, your A stands for area, your B stands for base, your H stands for height, your R stands for radius. You would have to know what each of those letters stands for, but you will be given a formula sheet. So like I said before, if you need to go back and look at these examples, you can. If you need to email me, you can. There's a couple extra examples in your book as well. We will go over this section and section 12.4 on